In this presentation, we're going to summarise the toolpath setup for the Lionhead door knocker. So as we know, we're working with three parts: the base shape, the handle, and the face shapes. Now with all of the parts, we'll be running basic 3D roughing toolpaths with a 1/4 inch end mill, basic 3D finishing toolpaths with an 1/8 inch ball nose, and then we'll run basic profiling toolpaths with a 1/4 inch end mill. We'll also run a simple pocket toolpath to assemble the face to the base shape, where we'll encounter two-sided machining to cut the recessed areas on the bottom side of the face, and then we'll also look at two-sided machining to create the full 3D handle. Now all of the toolpath files that we'll be discussing in this presentation can be found in the Toolpath Summary project folder. So let's take a look at each of these in a little more detail. We'll start by looking at the base toolpaths. So to begin, we'll look at the file setup. Now in the file setup, we'll set up various vector boundaries. And the reason for that is, if you take a look at the model here, we only need to run a 3D roughing and 3D finishing toolpaths on the 3D areas. So we're just eliminating the tool going onto the flat areas that we've got here, the top of the base shape and this area here by the chin, so that we just run 2D toolpaths for the top, and then we can just concentrate on the 3D toolpaths for the actual 3D parts. And that's why we've set up vector boundaries here. And you can take a look at the file and see that for yourself. We'd also double check the model height, so the top area here is going to be 1 inch high. We'd then move on to the toolpath setup, and we'd start by setting up our material. So this is where we set up our virtual with our physical setup. So start by looking at our Z0, we're going to put that at the top of the block. Material thickness we're working with is 1 1/4. XY position will be in the lower left hand corner. Then we move on to the model position in the material. Now the model that we're working with is 1 inch, and I want to create a pocket for our keyway that's going to be 0.15 inches on top of our base shape. So what I'm going to do is place a gap above our model of 0.15, assuming that I'm working with flat planed material. Then we'd just run a pocket for the keyway, like you can see here, and then we'd run our basic 3D roughing and finishing toolpaths along with a profile cutout with tabs to secure the part in the material block. Let's have a look at the toolpaths for the face. Now this is two-sided machining. So to begin with, we're going to open the face file, the model that we've got, and what we'd do is we'd just do the standard, check the model height, and size that up accordingly if you wanted to. We'd also add in some 3D tabs. Now the 3D tabs folder can be found in the Toolpath Summary project folder, and so we'd put these tabs in, and the reason for that is because when we come to cut the top side of the face, we're going to have the model position in the material block right at the bottom, and so we're not going to have room for a profile toolpath to create some tabs that way. So we're going to do it this way by manually adding in the 3D tabs, and that will make more sense when we have a look at the top side of the face. Now the key to two-sided machining is your alignment. So what we're going to do is we're going to draw 3 circles. We're going to place them asymmetrically, and these circles are going to represent the holes for our dowels. So we're going to use the dowel method to align a material block to our spoil board. Now if you're not familiar with two-sided machining or this asymmetric dowel method, there is a tutorial available on the support site called Two-Sided Machining Leaf Bowl. There's also a practical video that goes alongside with that tutorial that shows the physical side where we set the material up on the machine along with cutting that out, and you can see that process of us flipping the material over to align the dowels into the spoil board. And then what we'd do is we'd save that file, and then we'd save it a second time but change the name of it to represent the underside of that face shape. So we're going to have a top and a bottom. Now in the setup for the bottom side, what we need to do is take all the vectors that we've got in there, and we're going to flip them about the centre horizontally, and that's what will get us our correct alignment. And you can double check that over the two files by copying and pasting the vectors in and flipping them to see if they align up perfectly together. What we also need to do is create the handle recess shape in the bottom side. So we'll just take the vectors that we did for the base shape and just recreate that recess shape along with a zero plane so that we have something to reference that recess shape from. So let's have a look at the bottom side. So we're going to machine the bottom side first because we're just working with recessed areas. So to begin with, we're going to start by looking at our toolpath setup. So we're going to look at the material setup first. So we're going to set Z0 off the top of the block. XY position will be in the lower left hand corner. Material thickness that we are working with is 1 inch. The model position in the material, we're going to push that all the way up to the top of the material block, again assuming that we are working with flat planed material. And then we're just going to run our profile dowels to begin with, and what we're going to do there is just drill partially through our block of material those alignment holes. We'll then move on and create the pocket for the keyway, so we're going to go in at 0.15 so it matches that of the base shape, and then we'll just run a basic 3D roughing and finishing for that handle recess. So now we'd move on and would look at the toolpath setup for the top side of the face. So first we're going to start by importing our 3D tabs and positioning those around the face shape. We'll then create a vector boundary of the face and then offset that outwards, and that vector, the offset vector, will represent the area that we're going to do a 3D roughing and 3D finishing toolpath with. Then we move on to the toolpath side. So the first thing is our material setup. So the material setup is exactly the same, however we just need to alter the model position in the material. Now the model position in the material, we want to push our model all the way down to the bottom of the material, and that's because we've already essentially machined the bottom side where we had that pushed all the way to the top, and so that means that the two are going to be aligned in the material block. The first toolpath we're going to run is going to be the profile dowels toolpath. Now we're not going to cut into our block just yet. What we're going to do is cut our dowels into the spoil board. Now these dowels are the mirrored version of the dowels that we cut on the underside of the material block. And so we're just cutting partially into our spoil board just so that we can register the two sides so we get correct alignment. Once we've done that, we can then affix our material block onto those dowel positions, and then we can start to run our basic 3D roughing and 3D finishing toolpaths. So let's have a look at the handle toolpaths. So again, we're doing two-sided machining in this case. So for the file setup, we're going to add in those 3D component tabs, and again we're going to create a vector boundary, and we're going to offset that for our 3D roughing and 3D finishing toolpaths. We also need to draw in three circle vectors that are going to represent our dowel positions, again in an asymmetric fashion, so that when we flip that over it can only be aligned in one way. For the toolpath setup, we're going to just profile the dowels, and then we're going to do basic 3D roughing and 3D finishing for the main shape of our handle. Once we've done that, using that file, what we're going to do is select everything and flip the part about the centre horizontally. What we'll do then is recalculate our toolpaths, and we'll just make a note on the dowel toolpaths that we're only going to cut through the spoil board. And so that covers all of the toolpaths to cut out the line head door knocker. Now if you plan to actually machine the files, then it's very important that you calculate all the toolpaths using parameters and settings that are safe and appropriate for your particular machine, the tooling that you have available and the material that you are using.